Hi all. So this one will be a little bit shorter video than some of the ones we've seen previously. This is just to introduce us to the periodic table and how the periodic table is laid out. The periodic table in general is a tool that we are going to use continually throughout this course. I am not going to make you memorize the periodic table. To me, that's just silly. There are some chemistry instructors out there who still do that, who say you need to memorize the atomic numbers and atomic masses and the names and symbols of the first 35 elements. That's just stupid. The periodic table is a tool which I will teach you to use, and you will have access to using the periodic table and everything that we do. And so we really need to know some of the different terminology and, generally speaking, how the periodic table is laid out and some ways that we can use it as a tool throughout the semester. And so one thing to note is that one of the ways the periodic table is laid out is that metals are on the left-hand side, non-metals are on the right. And we have metalloids kind of in the middle. And so let's actually look at an image to illustrate that. And so metals are all in blue here. So one thing that you'll note is that really that's the majority of the table. And so we have to remember here, we have to start to think about distinctions between how we define something scientifically or chemically and how things are used sort of in everyday usage. In everyday usage, we think of metals as things like iron, nickel, copper, gold, silver, palladium, platinum, some of those typical things, titanium, some of those typical metals that we think of when we hear the word metal. From a scientific standpoint, though, metals are also things like sodium, magnesium, potassium, barium, lead, which you probably figured as a metal anyway, but bismuth, and some other things that you wouldn't necessarily think of as metals within your own head, but they definitely are from a chemical standpoint. So one exception to the sort of everything on the left rule is hydrogen. We do place hydrogen right here in the periodic table for reasons that we'll see a little bit later in the course when we talk about electrons and how those are arranged. Hydrogen is absolutely a non-metal. We just place it over here. So that's something to be aware of. It's a discrepancy to be aware of. And so we have our non-metals here in the right-hand side. And we do have this little zigzag line coming down through here. Everything that touches the zigzag, with the exception of aluminum. Aluminum is absolutely classified as a metal. But everything else that touches this zigzag line is known as a metalloid. It means they're kind of in between. They have properties of both metals and non-metals. Speaking of properties, the basic properties of the two, metals are shiny. Metals, by and large, exist as solids at room temperature, one exception being mercury, which is a liquid at room temp. Metals are good conductors of electricity, and they're flexible. Non-metals are not shiny. They're fairly dull looking. They can exist as either solids, liquids, or gases at room temperature, depending on the type of non-metal we're talking about. They're poor conductors of electricity, and they're fairly brittle or hard or soft. They're not flexible and malleable like metals are. Another way that we think about the groupings and the arrangement of the periodic table is we look at elements that are in a column. Elements that are in a column have very similar properties, again, for reasons that we'll look at a little bit later. And so elements within a column are called a group, or they're sometimes called a family. Groups 1A to 8A, let's look at what that means here. So in this section and over here, sort of skipping this middle section, these two blocks and this big block here are called the main group elements. Okay, sorry, I paused the recording real quick. I don't know if you could hear in the background the baby wailing upstairs. He's making some new teeth, and that's pretty painful for him. But anyway, so on the two sides of the periodic table, those are the main group elements, and that section in the middle are called transition metals. We also have some very specific names for some of the columns. The very first column here, these are called alkali metals. The second column here, these are called alkaline earth metals. We also have some names for the columns over here. This column right here, next to last, These are the halogens. And then here in the very right-hand column, those are called the noble gases. And having those names for those just give us an easy way to talk about some of the different properties. Alkali metals are all going to behave fairly similarly, both physically and chemically. And so being able to refer to them as a family name like that, as a group name like that, makes it convenient for us to talk about some of those properties. And this just gives a depiction of what I was just talking about. So our alkali metals, our alkaline earth metals, our halogens, our noble gases, we have our main group elements, and we have our transition metals. We also have the lanthanides and the actinides down here. We're not going to really work with them in this course. We also have what we call, and I mentioned this, I think maybe in the first lecture, but what we call building block elements that are the very basics that we need for all structures within us: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. We also nutritionally need certain macronutrients in amounts roughly equal to about 100 milligrams per day. Things like sodium, potassium, magnesium, calcium, phosphorus, sulfur, and chlorine. We need to continually ingest because they're used for various processes within our bodies. We also do need various micronutrients, less than 100 milligrams a day. So we need less of those, but those are things that are also essential for some overall health. And I'd shown this slide earlier, but this is where we would find some of those macro and micronutrients, and so in some of the various places that they're used in our body. And so that's a very brief look at the periodic table and how it is set up. We'll look at it a little bit more detail later, but this gives us some terminology and some ways that we're able to start talking about the periodic table as we go on. That's it.